A simple look at the data in our state list table shows us we have 53 records, and all states and territories listed of importance have values for the state ID field, the state name field, the region name field, and the landmass field. Now, when we look at the metadata of this table, what we see is that it has no keys and it has no indexes. So how is this going to affect what we're going to do next? Well, let's take a closer look at this data and notice we have a mistake. Colorado is abbreviated as CO and Connecticut is abbreviated as a CO. It allowed that even though Connecticut should have been a CT. There are no key constraints preventing duplicate records from being entered into this table. Another thing you may notice is when we get down to NH for New Hampshire, we have the entire record listed twice. It's a total duplicate. So it's probably time to scrub this data. And after we scrub the data, we want to make sure we don't allow duplicates in again. Let's fix the CO Colorado Connecticut problem first. Type update state list, and we're going to set the state ID equal to CT, where the state name is equal to Connecticut. Let's select this query and then run it. Okay, that fixes one of our two data impurities, but how about the New Hampshire duplicate? How do we get rid of just one of those records? Simply type delete top 1 from state list where state ID equals NH in single quotes. Run the delete statement. To check to see if we've gotten rid of our duplicates, let's run a select query. We can see that Colorado and Connecticut each have their own state ID. And we only have one New Hampshire. And we're down to 52 records because we got rid of one duplicate record. Okay, let's put a primary key on the state ID field of the state list table to make sure SQL will not allow any accidental or intentional duplications. Let's type alter table state list, and we're going to add the constraint, and we'll call it PK for primary key, underscore the name of the table, state list, underscore the name of the field, state ID. What type of constraint is this? A primary key, and we'll leave it as clustered. And we will set the state ID to be in ascending order. Let's run this. And let's expand our tables and take a look to see what we've done. In the Object Explorer in JProCo under the state list table, refresh your keys folder and notice the creation of this new primary key. Also refresh the indexes folder, and it looks like we have a new index. We have an index named after the primary key, and it's set as clustered. Well, let's see if this really protects us. Let's attempt to update the state list table, and we're going to try to set Connecticut back to CO. Update state list and set the ID to CO where the state name is Connecticut. Okay, let's see what happens now. It says, violation of the primary key. You cannot insert a duplicate key into state list if they have the same state ID. Okay, so is all well in our state list table? Okay, well, it looks like our Colorado, Connecticut thing's resolved. Everything looks pretty good. Wait a minute. The District of Columbia has 68 square miles of landmass. How can it have a negative number? Looks like a few negative numbers got slipped in there. I don't know exactly how many. Oh, here's another one. So what I'm going to do is just say, hey, the numbers are right. They just have a negative in front of them in a few situations. Let's go ahead and update the table to flip the negative back to positive if it's below 0. So we're going to set the landmass equal to landmass times -1, where the current landmass happens to be less than 0. Run the update statement. Wow, 4 rows have been updated. In querying the table, it looks like we have all positive numbers for landmass. Well, it would be easy for somebody to update or insert a new record with a negative number. So we're going to add what's known as a check constraint, and it's going to check to make sure the number's positive before adding it in. Let's write alter table date list, and we're going to add a constraint called CK for check state list, and we will check the landmass. Now we're going to check it to make sure that the landmass is indeed greater than or equal to 0. Run the alter table statement. This command's completed successfully. Now, any DML statement that tries to put negative values in the landmass field should fail. Let's run this update statement that should try to update many landmass values to negative numbers. That statement that causes those negative numbers, that's not going to work with this check constraint in place. So our update statement scrubbed our data and made sure all the numbers were positive, and the check constraint ensured no negative numbers will start coming in. Again, let's look at our state list table. Notice everything's pretty good. Alaska's our biggest state. It's got about 600,000 square miles of landmass, and DC's the smallest with 68. Well, let's look at the check constraint that we just made. Let's expand constraints, and notice here is our check constraint. Now this prevents the numbers from getting too small. Okay, well what about a mistake in the other direction? For example, let's say somebody entered the landmass for Alaska, and they had the numbers right, but they were entering square meters or square feet accidentally. So they put 65 million square miles. Now, there isn't even 65 million square miles in the whole world, so I'm pretty sure Alaska can't be that big. If you were to run this update statement that puts 65 million landmass in for Alaska, it would accept it. Is Alaska really bigger than the planet? I don't think so. So let's update this and fix this back, and make our check constraint just a little bit more robust. Type alter table date list, and we're going to add a constraint called check state list landmass. Wait a minute. We already have one called check state list landmass. We won't be able to create that unless we get rid of it first. But let's finish our logic. We will say landmass has got to be at least 0, but it can't be larger than the entire United States, which is just over 2 million. Delete the original CK underscore stateless underscore landmass constraint and recreate it with this new code. Now let's go and try to make Alaska ridiculously large. And it says, hey, I'm sorry, I checked and you are not between the acceptable ranges. You've got to enter a valid number. And there we go. It protected our data based on what we specified as the logic in the check constraint.